Welcome to the deep dive. Today we were peering back the layers on what seems like a really specific piece of industrial tech. The Thor broadcast F-8CC-B-TxRx kit.
Right.
And our mission here is really to understand why, in an age of, gigabit internet everywhere, we still need these super specialized systems just to send a simple on-off signal. So, okay, let's unpack this. We're looking at a system that's built for one thing, really. It takes a basic electrical command, like flipping a switch,
Exactly.
and it shoots that command miles away using light. It feels like this is all about extreme reliability for the absolute simplest kind of data.
It truly is. At its heart, this is an 8-relay bidirectional contact closure system.
Okay, that's a mouthful.
It is, but it just means it manages 8 separate electrical control channels.
Yeah.
And it lets you send and receive signals at the same time in both directions over just one fiber optic cable.
Let's nail down what contact closure actually means in simple terms, because we're not talking about digital packets here, right?
Not at all. This is pure electricity. Think of a light switch. When you short 2 pins on one end, the transmitter, that exact same action closes a circuit on the other end miles away.
So it's a dedicated remote on-off switch.
That's the primary function, yes, that simple dry contact closure. But the sources show it's a bit more flexible than that.
Okay.
It's not just closing a circuit, it can also handle actual electronic signals, specifically 5 VPP TTL pulses.
Okay, wait, 5 VPP TTL pulses. That sounds like pure jargon. What are we talking about there for anyone not familiar?
Think of it as the basic language of computer chips. TTL transistor logic is just a common way for electronics to talk to each other very, very quickly.
So this kit isn't just sending a simple on signal.
Exactly. It can carry rapid, repetitive pulses, the kind used in precise timing or control systems. Plus, it's flexible. You can set it up for a simple point-to-point link or a more complex daisy chain.
This is where it gets really interesting for me. If all we need is an on-off signal, why not just run a huge, cheap copper wire? I mean, isn't using expensive fiber optic cable just massive overkill?
That's the core question, and it's why this product exists.
Yeah.
Copper has huge limitations that fiber just completely solves. First one is distance.
Right, signal drops off.
Dramatically. With copper, you'd need repeaters every few hundred feet. The sources confirm the base model of this kit. It handles 20 kilometers.
20 kilometers, that's what, over 12 miles?
Over 12 miles. On single-mode fiber with no signal degradation.
Wow. Just for an on-off switch. That really speaks to needing to centralize critical controls.
It does. But honestly, the more critical factor is environmental purity.
What do you mean by purity?
Electrical noise. Copper is an antenna. It's incredibly susceptible to EMI and RFI, that's electromagnetic and radio frequency interference. Think noise from big motors, welding, radio tower.
And fiber is just glass, so it's immune.
Completely immune. And that brings up the real industrial killer, ground loops. Imagine 2 buildings miles apart, tied to different power grids. If there's even a tiny voltage difference between their electrical grounds, a phantom current can flow through your copper line, and it will corrupt your signal or just fry the equipment.
But with fiber, you're using light, so the electrical systems are completely isolated.
Exactly. That purity is non-negotiable for a reliable infrastructure.
So you get speed, total immunity from interference, and you guarantee that simple command gets there every single time. And the sources say it's plug and play, right? No adjustments needed.
Yeah, you just plug it in, LEDs tell you everything's working, and that robust design is critical because, this isn't theory. This is the invisible backbone for so many systems.
Like what? Where do you actually see these things deployed?
The sources lift all the high reliability areas you'd expect. Traffic signal control equipment is a big one.
Makes sense.
Also building automation, access control systems, and the really critical ones like fire and alarm systems. If a fire damper needs to close, that signal has to get through. No errors.
And to give that some context, the specs are just. They're serious. The unit can operate from minus 20 degrees C up to a scorching 75 degrees C.
It's built for punishment, and that durability is quantifiable. The MTBF, that's the mean time between failures, is rated at over 100,000 hours.
Which is, what, in real terms?
It's over 11 years. 11 years of continuous 247 operation without needing to be touched. It's gear you install in a box and forget about for a decade.
So what's the big takeaway here? We've looked at a kit that takes the most basic electrical command, the switch flip, and turns it into this incredibly robust long-haul signal. It ensures critical systems stay perfectly synchronized over huge distances without any risk of corruption.
Right. It's this paradox of modern tech. The simplest message needs the most sophisticated delivery system to be reliable. And if you connect that to the bigger picture, just think about this for a second. If one of these kits handles 8 bidirectional channels for traffic lights or security doors, how much complex real-time coordination is happening right now across an entire city using this exact kind of technology? It's these hundreds and hundreds of tiny, simple, reliable on-off signals that allow the machinery of a modern city to run safely every single second.